If you've been looking around on the GitHub, you might be forgiven for asking, is the project dead? What's going on? It started so well, it was so active, but there's been nothing for ages. But come on, you've seen the title of the video, right? Well, that was self-indulgent, wasn't it? All of that, I guess, is to say that I have opened a Pandora's box of bullshit. Alright, so let's dive right in. What I'm going to do is I'm going to split this video up into two parts. One is going to be about all the new updates and the things that have changed, and not just multiplayer, there's a couple of other small things. And then the next part is going to be more about the dev process and the hows and the whys and stuff, because I've had a bunch of people ask me about how to deal with massive spaces in multiplayer games, and it's quite an interesting topic, so I'm going to cover that. You can ignore it. I'll put a timestamp in the thing down below. Speaking of which, I would annotate the video, but I don't have enough subscribers, so if you would be so kind and press that thing so I can have a channel name that isn't... That would be cracking. Anyway, okay, so the first thing you're going to notice is that the main menu has changed. It's now got single player and multiplayer, two distinct modes, which is not super surprising. Architecturally, under the hood, it's the same thing. So when you go into single player, it's starting a local server, and it's not broadcasting, but it's the same code base, which is really important. So if I go into single player now, all of those old menus have been rejigged around a little bit. Other than that, they should be exactly the same as they were before. Now, if we go into the multiplayer menu, we have the ability to either host or join. Now, you must understand, I do not have a relay server set up yet, which means we're going to have to do this like it's the late 90s and early 2000s, and that is, if you want to host a server right now, you're going to have to learn how your router works, you're going to have to forward the port to your computer. It's just the way it works right now. When I get it all on Steam and everything, we'll use a Steam relay and it'll all be done for you. But as it stands, oh, that is a point. I haven't allowed you to set the port. Well, the port is 7777. So when you click on join, you have a server port. It's actually pointless, I've just realized, but that port is what you're after, so you can forward any arbitrary port, really, to 7777. Then it will work. Now, when you're hosting, you see different options to what somebody who joins sees. So if I open another one now, then I can take this client version, which is just going through localhost right now, which is fine. You can see that I can't change any of these settings, which is ideal. I can type messages, and we see them in there, that's all cool. I can change these, and they're reflected in the client. Brilliant. The password works, the max players works, and at the moment, this is only free roam. I'm mostly interested in testing the multiplayer code before I get too far into all of the rest of the weeds of making it work with different game modes, because I actually really need to think like logistically about how the UI works for levels. Right now there is one test level, and that kind of sucks. I need to make something that properly stores and shows different maps, so that's going to be a focus later on. Anyway, let's jump into the test space station, sure. And let's give it some spacey... Oh yeah, I actually need to ready up. So yeah, the clients need to signal that they're ready with this little tick box. Once everybody's happy, the host can start the game. Now, you're going to notice as well that there is this nice little targeting system going on here. You don't have any manual control over this. I can't say I want to target this particular client or anything like that, but it's good enough right now that it allows us to see other players and their distances, and it works over infinite distance basically, as far as it can render. So that's really cool. That's useful for when you're just messing around and hooning about and stuff like that. Other than that, it does just kind of work, which is cool. Now, one thing that's useful if we're talking about massive terrain worlds is that the clients have a different restart functionality. They don't start at 0 anymore. They can walk directly to the host, and it uses some complicated system of figuring out where is a good place to actually place the player, and it will set the orientation to match. So if I click this now, I'm somewhere within the vicinity of this other player. And if they're traveling, then you're going to have to start and keep up with them and so on and so forth. But that's good enough if you join a game and you just want to jump straight in with all your pals. If you leave the game as a client, you just drop straight back to the menu. But if you leave the game as the host, we pull everybody back with us into the lobby, and that means we can make changes to the game and then start off again. So I can now just jump into a terrain world, pull everyone along with us, ready up. It synchronizes the loading, and in we go. Although I've just realized I need to actually set a seed, which is something I haven't considered. Anyway. And now we're in this lovely terrain world. A couple of other little things that have changed. I've done a lighting pass on the terrain worlds in general and the shadow system. The shadows now have more layers of cascading, and the shadows are projected off the mountains. I really like the effect it gives. Obviously on certain maps where the light source is very low to the horizon, it makes them very dark on one side, so that's just another thing that we'll have to fight against when we're making maps in it, and I think that's kind of a good thing. I might have to play around with the ambient lighting a little bit, so if it's too dark, please let me know. So basically that is multiplayer in a nutshell. It's super simple, but my god, I cannot begin to tell you how much work it was to just rip out the entire game and then switch it out for this server client architecture and get things loading in the correct steps and synchronizing state, and but it's done now. So what I'm after more than anything right now is for a bunch of people to test it, stress test it, and tell me what they think, if there's any like major concerns or problems that they have. Was it a nightmare to get going, that kind of thing. I've not done any motion smoothing and motion interpolation yet. It is something I've had to play around with, but I didn't want to get lost in the weeds of doing something like that while, you know, the lobby didn't work and so on. So right now it's just going to saturate the network with as many requests as possible being like, I'm here, I'm here, I'm here. That's not ideal. Really, we want to be doing it maybe every 50 milliseconds or 100 milliseconds, and then interpolating based on the velocity, because we do have that we can do some prediction work and then like kind of smoothly bring it back to where the server says it should be. One last thing I want to touch on before I jump into the technical side of all this crap is that there has been a small but kind of significant change to the flight model. I really like it, and I really want to hear some feedback on this. So I tried playing around with sharing thrust between different axes, and like the laterals and the throttle last time. Wasn't good. People hated it. But I've done something that's a little bit of a hybrid approach. So let me tell you what I mean. In the previous version, we added a thing where if you're boosting and you pull back on the throttle, the last 40% of the axis would actually pull back on the forward thrust, and it would reduce forward thrust by 40% maximum. So that doesn't mean you can stop or anything, but it did mean that you could reduce the amount of vector change that boost was giving you, and it meant that you could pull up and use your lats and things like that. What I've done is, for a start, I've made that go across the entire reverse axis, so just pulling back a little bit does make a difference now. Like, it was not just the last 40%, but also any excess remaining can be piped into your lats. Now what that means is that you can very sharply turn around and use your lats to pull yourself back up again, and I really love the feeling of it. And it means that it's a lot more dynamic, in my opinion, how much you move the throttle. It really annoyed me before how little the throttle was useful, especially on a HOTAS, because, you know, one of your main axes is that throttle. So give that a try, let me know what you think. It does work with flight assist, because flight assist kind of figures that kind of stuff out on its own. So if you're pulling back on the throttle, or if flight assist is pulling back on the throttle, it will automatically increase the thrust in the lats to get you where you need to be. So you don't have to use flight assist off to benefit from it, but you'll probably be able to feel it more if you do use flight assist off. Speaking of which, there is a small bug fix with flight assist whereby if you change the default flight assist now, it will actually remember that and do it in the game. Like before, it would only do it like every time you started a game. If I change this to, like, I don't know, rotational assist only now, then yeah, it's worked with just the rotation. It's also remember the default for next time and so on. People were getting confused because they were using that instead of setting a binding for it, which makes sense, because if you're not going to bind it a lot, then if you're not going to change it a lot, then it's yeah, that's fine. So cool, have a play with that. Let me know what you think. I'm very, very intrigued to hear what people's opinions are, especially on the netcode, because we've only stress tested it. We've played with 4 people, and it was a fucking riot. It was brilliant. I had a great time. Next steps for the game, I think, well, first of all, I'm going on holiday for a couple of weeks and turning my brain off, and I can't wait. Then I'm going to make a roadmap, I think, and the next big thing is going to be a visual and audio pass, because it's been desperately needed for a while now. I think we need, we've got this awesome looking ship from Ray Jefferson in the Discord. We've got some really promising sound effects coming from MonoHive on the Discord. And I want to do a full pass to make it so that A, these sounds sync between different multiplayer instances, and B, we have things like visual thrusters, because now we can actually see the ship from the outside when you're playing in multiplayer. It does look really strange having this completely silent block of ship just, you know, moving around and doing its thing. I think there's a lot we can do there with like engine sounds, with thrust sounds, splitting the boost sound up so that the front-loaded part of the boost comes from in front of you. It would be great for 3D sound, especially in VR. And yeah, after that, I think I really want to get some interesting geometry to fly around in. I like the test space station, which, by the way, I've done a collision pass on it now. You should be able to go into all the little nooks and crannies and stuff. I just kind of threw that in there to test things, but people actually do want to fly around with it, which is cool. I want to get a more complicated version of the space station in, like a proper big modular thing that's more fun to fly around in, similar to the kind of installations in Elite, really. Then I want to look at longer term building out the systems for different maps, building into it a simple campaign system, similar to Trackmania, where you have like different coloured leagues that have different maps with different medals to get. That's going to be my big focus, I think. So cool, have a go, let me know what you think. It's been awesome. Right, let's talk about the hows. So, when we're dealing with these massive worlds, there is a problem to do with precision. Now, I'm not going to go into technicalities of floating point. There are way more qualified people to talk about that than I am. But the bottom line is, the really high level stupid interpretation of it is, the more big numbers you have, the less decimal places you have. That's the kind of top and bottom of it. It's much more complicated than that, and don't at me, I don't care. But the bottom line is, the further away you get effectively from 0 in your world, the less precision you have on the small details, right? So with that in mind, understand that in this game, the scales are accurate, so to speak. This cockpit is about 1 unit in width, roughly, give or take, and 1 unit in this game is interpreted as a meter. So that means all these little buttons and dials and switches are in the order of centimeters and millimeters apart, especially all the small details and the vertices and so on. So if I turn off my floating origin fix, which we'll get into in a second, and I just blast into it in a direction, what we're going to see is that the player and the camera, critically, is going to get further and further away from 0. Now, if you're coming to this video looking for advice on how to do this, you've almost certainly encountered this, but I'm trying to explain it for anybody else who's interested. Now you can see all the dials are starting to flicker, all of the vertices are starting to pop. We're losing precision on the micro level for each of these vertices. Now, the further you get from 0, the worse and more pronounced this problem becomes. And you can see at this point, it's basically a juddering mess. The UI is starting to break down, everything's flickering, it's not good. And when you're talking about a game where you're moving at these kinds of speeds in an infinite world, that's a problem. So, when I turn this thing on, boom, it just fixes it, like in real time. And that's super cool, but let me tell you what it's actually doing. So, on the game level, this is the world, and each of these large squares is about 1 kilometer. This thing that you can see yeeting across the landscape, that's the player ship. And every time it gets 1,000 meters, about 1 kilometer, well, exactly 1 kilometer from the origin, we do a floating origin fix. We place it back at 0, we record the difference in moving it back, and then we do the inverse to the world transform. Everything that's the geometry of the world gets shifted away, and that allows us to just keep having our camera close to 0. Now you can kind of see why that's going to be a little bit problematic when you're trying to synchronize positions on multiplayer state. So let's talk about that. So this is my first pass at this. What I wanted to do before I made any changes to Fly Dangerous was to distill the most risky problems, or what I thought was the most risky problems, into just dealing with it in a small proof of concept. So this is effectively a 2D version of that problem. So this is a similar kind of host server client architecture. You can start a game. It's a very, very simple game, but we have a rigid body kinetic object that you can move around as a player. It can bounce off of these pieces of geometry, and you can have multiple players in the scene. So if I join on this other game, you can see we can move them around, we can bop into each other, sweet. So that was like my starting point. And I thought, you know, I'm not naive. I know that multiplayer is complicated and it's not just a tick box in Unity, but I thought this was going to be my biggest problem, is getting two clients to sync up. And, you know, I was so naive. This took me a few days and I was like, brilliant, the rest of this is going to be smooth sailing. We'll get to that later. But anyway, okay, so for demonstration purposes in this particular game world, I've placed a bunch of different walls. Now, there is a reason that they are separate parents that, again, we'll get into shortly, but these are the walls that you can see around us. Brilliant, I can move them around. Obviously that doesn't get reflected on every client unless I turn them all off, but there we go. These distant walls are at 1E08, so that is 100 million meters away from origin on the x-axis. Now what I can do is I can take my player, which is this one here I believe, yep, and I can set my x value to that, and I'm immediately transported there. And when I press enter, I've been set to some close but not exactly that value, and that's because the actual position is now being tracked by the floating origin fix. These are at that position, and you can see that they all render correctly. If I zoom in a little bit, is it? Free aspect, that's what I'm after. You can see everything's kind of shimmering because, you know, this is a very simple game and the camera's very far zoomed out and stuff. But they are moving over large distances. You can see, like, this is, again, conceptually, in meters, we're moving very, very large distances. And I can jump into the game, and I can find that player, and I can zoom right in on it, because conceptually, to the editor, this player object, oh god, yeah, this player object is near to 0, right? This is a child of this parent, which is only 6 and minus 7 from 0. So the editor's no problem with any of this. And you can see that if I take my other player and I also move it to that X position, now we're in sync. We're in position, we can bop into each other, the physics works, everything's cool. I believe the physics uses continuous speculative positioning, which it shouldn't do, but, you know, proof of concept, it should use continuous, but it doesn't matter. The important thing is that the collisions work over these insane distances. Now I can go even further. I've got these extremely distant walls, which are placed at effectively E14, which I believe is a quintillion meters away, something ridiculous. So let's do that. And now, again, you know, we've moved all the way over there, and that works fine. Now, the reason that we have a world transform object and a bunch of other objects, and then all of our individual pieces of geometry attached to those, is because what we're doing is effectively segmenting our world. Now, when you think about what a transform is in Unity, you're starting at the parent and working down one at a time. That means if we have a starting point of some ridiculous value, then all of our other children objects are going to have the same problem, right? But when we're moving these massive distances, what we're effectively doing is just saying, right, this thing is 15 quintillion meters away, say, or 1.5 quintillion, it doesn't matter, and my player is minus 15 quintillion away from origin. So 1 minus the other, now we got 0. Now we can do the work on the individual geometry level, and then we have basically perfect accuracy again. We're back to 0. So I'm forcing the world geometry to do the same as we're doing with the player. So the way that floating origin, at least in my implementation, works is very, very simple. A focal object registers itself, in this case our player, and the floating origin object, which is just a singleton and it just lives like as part of your game engine, it continually tracks its own origin. So every time it makes that adjustment, it puts that variable to one side and goes, this is how far away we are. Then it iterates through everything that is interested in the correction and invokes it with this new position. So it always sets our focal object back to 0, that's fine, and then anything can register interest in this. In this particular example, what I've done is I've got a standard world script that exists on every scene, and all of the parent geometry elements, parent geometry entities, are shifted by subscribing to this. The world scene just iterates through its children and goes, hey, this thing has happened, move, right? So we can see that here if I open up. By the way, this is on GitHub, it's open source, to have a play around with it. If this is something you want to see a very simple example of, I think is really, really useful if you're trying to solve this kind of problem for yourself. So we just have this really simple perform correction. It just registers its interest in it, iterates over all of its children, and offsets the transform. That's all it does. It's so, so simple. Now to get this to work over a network, we need to do something a little bit hinky, but it's not terrible. Now, I'm not using any off-the-shelf like mirror components or networking components to synchronize position, because it's not going to work over these distances, and especially if we're doing smoothing and the object keeps being reset to 0, we need to handle this manually. So I don't do any of that, I'm doing it through messaging. So I'm sending a command to the server to say, hey, I am here now, every single tick, which, tell me if I'm wrong, if there's a better way of doing that, but it works for me anyway. And when I do that, I go, here is the origin that I am at. This is my floating, like local client floating origin. Here is my position from 0, which is usually somewhere, well, it will be somewhere within a kilometer from 0. And here's my rotation and my velocity. That allows each client to figure it out on its own, right? So we're doing one thing with the world, and then completely separately to that, we're treating all of the players separately because they're sending through their own origins, and we're taking it away from what we know. That means we always end up with a position in relative space. I don't know how well I explain that, but again, please have a play around with this code if this is something that you want to do. It's not perfect, it's not, but it's simple. That is the important thing. It's a very simple, simplified test case, okay? And that has allowed me to get far pretty quickly in terms of at least the synchronization code. Cool. As for everything else in the hows and the whys and the... Honestly, if I was doing this again, I probably wouldn't use any of the off-the-shelf mirror components. They got me a certain level very, very quick. But it made things a lot more complicated when I didn't start with it. Now, if I was starting from scratch, I probably would use the off-the-shelf stuff and then kind of work within that framework until I needed to diverge. Trying to kind of hammer it into an existing project it was really difficult. I properly struggled especially until I got the idea of some of the concepts properly in my head. But even so, the way you manage connections, the way you manage kicking clients if you're at capacity or if there's a reason they're not allowed to join, sending messages to them, making sure they get picked up, that was an absolute nightmare. And feel free, again, like, all of the Fly Dangerous code is all on GitHub, so if that's something you're struggling with, how I've done it, there's a script in there called FD Network Manager. Basically, that's the network manager, and it inherits, and inheritance is great fun, isn't it? Isn't it great fun? Anyway, that's it. I hope that was useful to some people. Please come and join in the Discord. I'm always active on there. If anybody has any questions and they just want some general dev help, nothing to do with the game, come and hit me up on there. I'm happy to spend time with people whenever I can. And cool, yeah, let me know if that was helpful. Cheers, guys.